Well, hello, Dave. Is this everyone? Are you there?
I am here.
Yeah.
Hello.
So
Might have a few more people, drifting in, but I think you're good to go.
yeah, I like it to get going right away.
Okay.
So everyone can hear me
Yes.
and briefly see me. I turned the camera off, and due to bandwidth, that's probably good. So, hello. This is the first of the two OSLO 101 Introduction to OSLO classes. So that we had a little bit of some confusion on the dates, simply because this is the previous day where I am and where some of the participants are. So we're still Monday evening. Although last time I taught this class, I taught it from 1 to 3 a.m. my time and decided that wasn't such a good idea.
Where you located, Rick?
Yeah. So I hope everyone is ready to go.
Where are you located, Rich?
Idaho in the U.S.
Oh, nice place.
So yeah, Mountain Time Zone. So we're so right now it's 7 o'clock in the evening. So good. All right. I'll just go through a few intro things, a copyright notice, but how this class runs, it's very helpful if you have OSLO open. There's an understanding for our classes. They're very fast. And if you haven't used the program, don't worry. Next time you get on or as you use it, this class should still help you and should help you know how to look some things up and know how to help you use the program a little bit better. So really, we're trying to help attendees recall the class material. Questions are always welcome. If I don't know the answer to a question or I need to look at it, we always follow up on the questions to make sure. So some learning objectives are good just to give you an idea of how to effectively use OSLO's built-in capability is one goal in 101. We want to employ the built-in features in OSLO effectively. Yep. Thanks, Dave. You just said have a good class, everyone. And I have, I'm going to make sure all users are muted. Okay, great. So we don't have any feedback. If you have questions and you type them in, I'll try to see them. But if you need to unmute, that's certainly fine. There's a problem that I'm not sure this this first time I've done one of these on Teams, and Teams sorry, there's another person I believe maybe trying to get in now. Right when Dave left. This is the first time we've done this on Teams, or I've done this on Teams. Nope, I don't think so. Okay, so what we're trying to do is effectively use built-in features in OSLO, help them to solve your problems. We'll do a little bit of practicing setting up systems and optimizing, showing you how to use some of the performance features. Then there's a few other things that you get out of this class that people eventually learn, but maybe aren't completely obvious initially. One is differences between preferences and operating conditions. Have an idea of how OSLO is structured, and then connect you to our documentation. And the documentation in OSLO, it is in a few different places, but generally I find it's been very helpful for me over the years. Just a moment. We have somebody who says disconnected. He's here. Good. Thank you. Okay. So this is day one separated into 3 sections. The first one, as I say, this introduction especially, I go pretty fast just because it's a lot of interface things and you need to learn most people learn it as you're going, but I'll show a few things that really help if you haven't used a program like this ever or in some time, because Oslo's interface is very well done for what it does, but it's not like a lot of applications you would see now. So when you open it up, there are pop-up menus, there are toolbars, and there's a number of different window types that we're going to go through: graphics, text, spreadsheet, command line, and then there's even a few other types. And it's kind of like Windows, but not exactly, because the interface for Oslo actually predates modern Windows. And part of the reason why we don't change it is because a lot of users that are used to using it, there's no problems with using it. But if you're new to the field or just coming in and haven't used something like this, as I said, it's a little bit different than how a lot of applications now are done. But it's generally easy to use with just a few little exceptions. So the main window types are exceptions to normal Windows function nowadays. So we have a spreadsheet window. You can only have one spreadsheet window open at any given time. So here's a spreadsheet that's open. If I open another spreadsheet, it only keeps that one open. We also have graphics windows. So these are graphics windows. It's a little different looking than what we have on the screen here for you on the slide. And you can have 32 of these graphics windows open. And then there's text windows. You can have 2 text windows open. You always have to have one open, just like you always have to have a graphics window open. But it is possible to not have a spreadsheet open. And then there's this command line that's still sitting here, which I'll get to in a moment. One thing that's nice that we point out here in the slide is if we actually run some command, Oslo has a spreadsheet buffer that is in this text window. Graphics don't quite run like, these aren't dockable. There's a few other things that I'll show with them. It's a little bit different than docking, but the graphics windows operate off of a right click and then this button ribbon at the top. There's also ways up here in this upper menu to call different functions. So that's the window types, essentially graphics, text, and then sometimes a spreadsheet. As I was already talking about, there's a menu structure up here, and there's another row of buttons that we have up here as well. There's a default editor menu, and essentially the editor we're talking about is something where if you want to run if you have something that you do in text, so you can open it right within Oslo. So here's just a standard text editor that comes. We actually also include Notepad++. Some users never use this or don't do anything with it. Some users do a lot of the customization, which can be done especially in CCL in the program. And when you use CCL, having these text windows available is really handy. So I'll show you more of that a little bit later. There's also pop-up menus when you right-click on some things, but not everything has a pop-up menu. If I go over to this gray space, for example, there's nothing there right now. And many of I believe the spreadsheets don't always have them, although here we have some Windows-looking things. Oh, that's because I clicked in that row. If I just click in this gray space, nothing comes up. So sometimes you have to right-click in the correct area. Trying to make it where I can sort of see everything at once. Real estate here. There we go. This will work. Okay. So we have a number of different toolbars that I've mentioned. There are some here. It's actually, there's a number of them. They're not dockable. What that means is, for example, for this window here, we can't just grab and pull it somewhere else. It will stay in this location up here. but I can click here and I can change to any of these. On the graphics windows, it'll change to a different set of commands that you can run or different set of features you can run. On the text window, it's a little bit different because you can actually have multiple open at once. So there I had the image analysis open as well as the standard tools. On the graphics one, I believe we always have to have one open, but on the text window, you can actually have none of them open if you want. So they're slightly different, but not so, they're slightly different in terms of how many have to be open. Then we have one up here as well, which runs like the text one, where you can have multiple ones of them open. And if you have more things open than fit on one line, it should just go to a second line like it does here. So they are different than how Microsoft has them, but they have a similar functionality with the exception that they're not dockables, the main one. The other thing that we have that you'll notice here is in this main spreadsheet, there are some things over here that talk about reversing rows and cutting and pasting. Those can come in handy from time to time as well. The spreadsheet buffer also, or this, you can see if it's too small for how many rows there are. You do get a slider over there to go up and down. There's some other nice little things that this slide also says, such as you get little tool tips that even pop up. So you can see it's a pretty usable interface, but it's a little bit different from Windows. One pretty amazing thing about OSLO is you can completely reprogram the interface to be something that you want that's completely different. And we have had one user that for years has designed computer-generated holograms that did that with OSLO. He has a completely customized interface, which is the things that he has used to design computer-generated holograms. Okay, our main window styles is next. And here we have, I'm not going to say much about this. There's a standard style. There's a way to run it enhanced, which is how most people actually run it, where you have additional toolbars. I've been showing that. Basically, if you alter from the default, then you're running quote-unquote enhanced. Then there's a command basic style, which I have never used and can't even remember how to get it quite into that mode. And no one ever seems to ask. So I would just run as it is packaged. If you reprogram some things, you might have different buttons up here, different things on the menu, but otherwise you just run it the normal way. Mentioned the graphics windows, it can have up to 32 open. There's vector graphics here, so there's a lot of different things. For example, right here, I just have this picture of what looks to be a doublet lens. I'm actually going to switch to a different lens. We'll go to this demo triplet lens. I'm going to turn off this drawing window. But you can see here, this is the triplet. If I click and grab, here I can zoom in. If I double click, I come back out. Double clicking will update the window. I can right click to recalculate things or do some of these different functions. Zooming on the center, saving if I want to save to the hard drive somewhere. We don't have unlimited formats that you can save in, but that gives you an idea if you do some right clicking. You can actually even do other simple fancy things here, like inverting the background, which is nice on some kinds of graphics. And then to invert it back, you can come here. There's actually a preference that I might show later where you can make all of these dark or light. They can be resized. It's isometric. A lot of the graphics are isometric, so as you resize and rescale, they just kind of move around with them. I think that's pretty good to give you an idea of those parts of the features. If we click on these different buttons, obviously we get different graphics that come up in them, and some of them will have different recalculating new parameters. You can not only double click, you can also do update window using current data. One thing is a lot of what I show, there's many times 2, 3, or 4 ways to do different things in OSLOs, whether you're clicking with the mouse, whether you're finding it in some window somewhere, or right-clicking here, like to update the graphics window. You can also clear it here, and there's also even commands and things to type in, and sometimes there's things in menus. So I'll try to be pretty consistent. So there's some people that don't feel like you have to know every single way to do things. I tend to do things a certain way when I run, the way that I tend to prefer to use it, and it varies depending on what it is. With the graphics, I often hit these buttons. I tend to not look in the menus. Certain things I even run commands just because I find it faster. So don't be intimidated by that. Mentioned the text windows, mentioned that you can have these toolbars here that are optional. This spreadsheet actually goes to 4,000 lines, and there's a spreadsheet buffer. So you can actually, like, let's say this one is 5. You can actually use this data by just typing in the cell number, which is B3, and there's ways to use this inside of our custom programming, and it goes out to the machine precision. And believe it or not, this was one of the reasons why I first started using OSLO, mainly because I found that I could get it to do anything I wanted to do. It was extremely flexible, really easy to get at numbers and data, and I'll show more with this as we go through the class. Also mentioned the right-click support on things like clipping and saving things. There's actually also a command and a way to echo. If I right-click on this, there's a log which will save a log for you that goes into the private directory under olog is the name of the file. But you can actually also echo commands. So if I'm echoing commands, I believe this will work. You can see this told me the command that was run, but also it happened to show up here in this history buffer, which I haven't shown much on the command line yet. But you don't have to know what all this is. But if I wanted to know something about a certain command, that might tell me a name. I can go to help. I'll talk more about all the different ways to get a hold of information through help really soon as well. You can actually also turn off the output entirely, which is really useful when you are doing some programming things and you want things to run faster. Okay, next up are spreadsheets. So spreadsheets, as I've mentioned, we've got a number of them. There's a few little things about them that are a little bit different than other programs. There are actually some, you look at some of these things and you think you should be able to grab and make things bigger or smaller. You can do that with the overall window, but I can't really do that. These are set fields with fixed sizes. Unfortunately, this left to right one, oops, I grabbed the graphics window, has a fixed width. That's it. That's as wide as that goes. Part of the reason for that is because there's nothing else that we ever put into our spreadsheets that makes you want to go wider than that. Vertically, as I said, though, you do get a scroll bar, so that's variable. But notice it's only the bottom part that's really relevant. And even look at how it scrolls. It keeps the top part fixed. So this is the kind of stuff that I was saying. It's just a little bit different than a lot of Windows programs. There's ways to even get in here, and I can use right here. I'm using the mouse wheel to just go up and down. I can use arrow keys to get around in here. There are some things you can do by left clicking with the mouse. There's some other things, right clicking with the mouse that work. It turns out left or right click. These are little buttons that you can pick that pull down little menus. And there's other design programs that chose, instead of making things layered like this, they chose to lay it out a little bit wider. And then you find you're scrolling back and forth. So the negative with the positive with this choice is things generally look compact on the screen you're in, but the negative of it is if you have to find what you're looking for. So that takes a little bit of time. Generally, things we want to do to alter things like curvatures would be on this button, thickness, radius, and then we have a catch-all set of buttons here, or options here, that I'll talk about a little bit later. You can also have spreadsheets that call other spreadsheets, and then it becomes first in, last out. The old computer science type of term for that. I don't even know if that's where it came from. So let me just use wavelength. If I want to know what wavelengths I have here, I click on this. Now I'm in another spreadsheet. If I come out of this spreadsheet, even if I make changes or do whatever, I go back to the surface data spreadsheet. But that's not always the case. There is a way to get the wavefront spreadsheet open on its own. WSE is one way to do it, and I'm just showing this. Not that the example matters much, just to show it to you. Now, if I come out of this, I don't go back to the surface data spreadsheet because it's first in, last out. I don't have to get to this from the surface data spreadsheet. But if I do, then it's sort of subsidiary or hierarchically under the surface data spreadsheet. Okay, we're going to have some exercises now. It's very hard to do these exercises here in the class, so I have them here so that you can do them later on your own, but we will go through them, and I'll try to not do it too fast, but we do have to keep on track. So usually I keep spreadsheets closed when I open and close files. That's not strictly necessary, but every now and then you can get into a situation where the spreadsheet you have open doesn't happen to match the file that you've got open. So my best practice is to usually just close the spreadsheets. I know how to get out of that if it happens, but be a little careful that doesn't happen to you. I'll show a little bit more about that later. So here, let's just open up this demo triplet. If we go to the open lens, there's a way to go to public and private, which will move you right to the public and private directories that we ship. I actually have an examples folder here where I've put these. So I'm just going to go to the demo triplet example here. I also have a pull down menu that I can open these with. So here's the demo triplet. It opens up. It has this draw window on. This drawing window is one that if I change a number, oh my goodness, I'm on the curvature mode. I'll show how to change that in a moment. But here, let's just say I want to change one of these. I say, oh my goodness, because I never run in that mode and some reason I'm in it. So if I change this curvature, and this is 0.055 millimeters inverse, I change that. This window automatically updated. This window up here, note, it didn't really update or do anything. There, I just double clicked and updated it. So this window automatically updates. This is something that if it was easy to change, I think we might consider it because then we could lock windows and have them automatically update. But as it is now, whenever you make a change, just make sure to double click on the windows or update them in some ways. And if you really don't like this, there is a command called UDA, update all. And maybe we should actually put that in the interface itself. And UDA will actually update all the windows. Just to help people, I pulled up help here. I think UDA is update all. So this is update all. So if you just type in update _ all or UDA, it will update all the windows. There's some other Windows management functions here too. I'll talk more about the help in a little bit. Okay, so now let's do the exercises. So it says it came with the spreadsheet. I opened the surface data spreadsheet. If we just open this, we can open it from the main toolbar here. So this is where we open the main surface data spreadsheet. Another place you can open it is here under Lens. And then another thing you can do is just type in LSE, Lens Spreadsheet Editor. But it's actually the surface data spreadsheet, but the command name is LSE. So this is the most common way to open it. Is just hit this little blue lens. So there we go. We've opened it up. Now it says close it. Well, we can close it with either this green check mark or the red X. We haven't made any changes, so it doesn't matter which one we use. I'll talk more about that soon. So we close it. Now it says open it from the menu. So I open it from up here. And it says turn the draw option off. So I do that just with this little button here. I didn't talk about this too much. Some of these fields in here are actually ones where you can edit things. Some of them have pull down menus. There's a whole bunch. You can't change the EFL without changing the numbers. The wavelength, though, it even has a pull down menu. Some have pull down menus. Some don't have pull down menus. These are just buttons that open other spreadsheets. This is just a text field, text field, text field. So they're a little bit different depending on the function. We only have one configuration of this, but if I made two, the interface changes slightly because now I can do multiple configurations, which we just generically call Zoom. My apology, I cannot see. Maybe I could if I do this. Just a second. I'm trying to adjust so that I can see questions and mess around with this at the same time. Ah, there we go. Haha, now we're in business. Okay. Okay, so now it says, now we're on number 4. It says expand the main menu bar. So that would be this one. So to expand it, we just click on other things. I can reduce it or expand it. These exercises are just to make, just to have us look at different parts of the interface. Change the toolbar, excuse me, on the first graphics window. So here, changing it, I can change to this lens drawing. You see now it has different options up of what to draw. We can go ahead and do a wireframe, for example, there. I could go back to the standard tools. That wireframe is not on here in the same way. Then back to the plan view. The text window, I showed this. We can come down here and expand it out. The image analysis are not bad ones to have up. Actually, the ones I usually have up are the standard tools, and I believe the aberrations one. I like a few of these in here quite a bit. Now, notice it didn't give me the extra space here because we hadn't gone all the way out until it says it needs to go to the next line. So I expanded that out a little bit. I'll show a little bit more about that in a moment. So there's a few little quirks with the interface like that. Another one that is somewhat, you have to get a little used to it, is you have to stay within the OSLO window. So I can't drag this window out on the side of that. And this is the negative of the interface being what it is things that might seem simple like that would require a pretty big architecture change for us to do. So we keep it this way. And often whenever you change something like that, you create other things. So this is just the way the interface is. So I don't want to sound apologetic about the interface. I'm just telling you this is why it's a little bit different than other things. But I've been using it long enough. It never really bothered me much. But there are a few little quirks you do have to get used to. So opening a new graphics window from the menu here. Here in the menu, we can open text windows or graphics windows. They're up to 32. You could just do a new one. That would go right to 5. If I did open, it would let me actually pick the number of it. And I think it even allows you to do sizing and other things. You can also do the command GWO, which would allow you to open a window if you really wanted to do it that way. Let's see, we're now down. Oh, it says tile the windows. So let's say I've got them all jumbled around here. One little nice trick you can do is you could just do a quick tiling. Now, what it did here with the text windows, it made it big because it'll only tile that to be the size of this, of whatever spreadsheet window you have open. But tiling can be kind of nice depending on what you're doing. It asks us to click on any text and graphics option in an appropriate window. So if we click on the text and graphics option, I think we're talking about here to right click to pull up these different options. Oh no, Yes. So this is 9. So 9 is to right click to see what your options are. There are a few options here under the text window, but they're mostly text window. These have things that allow you to look at the graphics different ways, as well as recalculate using new parameters. I think the option that it's talking about is to click on these to show that as you click on these, it will run the different appropriate commands. So one thing we can do in here is have, of course, multiple things open at one time. Okay. I know day one's not the most exciting thing, so we'll move on. This next slide is just to show you some answers to some of these, or an idea of where these are, to click on the different text and graphics windows and to right click and all this sort of stuff. Okay, now one of the big topics in the class. So believe it or not, this is one of the biggest reasons to come to the class. In our spreadsheets, you will see that there's a check mark, an X, and a yellow question mark. Yellow question mark, really easy to explain. If you're on any window like this, I can click the question mark and the help will open to the page that's on that. I happen to still have the UDA open here. So when I clicked on this, let me go back just to home. Now, if I hit this question mark, you will see it goes to the surface data spreadsheet. If I go to this wavelength one and I hit the question mark, now it goes to wavelengths. That's awesome. I love that. Really good. Great part of how this works. But there's a really funny thing with OSLO. OSLO does not have an undo that operates like a normal Windows undo. It's another big architectural change to put a Control-Z undo or Control-Y redo within the program. It has not been structured for that. Instead, it's structured with this check mark, accept, and red X. So if I hit the check mark, well, let me just back out of this. Okay. So I come in here to this triplet. Oh, I didn't change this yet. I have to change this because people don't think in terms of this. So give me just a second. I'm going to actually do some. I'll just show you preferences, change everything within the program. No matter what file you open in, operating conditions go with each file. Somewhere along the line, I had changed to curvature instead of radius of curvature. And I believe if I open this, it'll update it. Yes, now it's radius of curvature. Okay, so now the numbers are in millimeters instead of 1 over the radius of curvature, inverse millimeters. So basically pretend I didn't start that way, because I did not intend to show that. So, because it could be confusing. So let's say we're in here now, and let's just say I changed this to 22. So I change it to 22. I have not saved it to the hard drive yet. It's just changed within OSLO. Now, if I hit the green check mark, it will accept any changes I've made since the last time this spreadsheet was open. If I hit the red X, it will undo that change. So I open it back up and notice it's 18.18. Now let me change it to 22, and I hit the green check mark to accept. Now it's changed to 22. However, I still haven't saved it that way on the hard drive. So if I come here and open the file back up again, oh, I didn't. I don't know if I opened the same file or not. Anyway, it should not be the same number. Sorry, it should be what I had saved on the hard drive. So this means you have to kind of keep in the back of your mind, when you have a spreadsheet open, have I made changes to it? Do I want to undo out of those changes? And if you undo out of those changes, they'll all be gone. If you hit the green check mark, that means your current state that's still not saved to the hard drive has accepted the changes from that spreadsheet. So I hope this is understandable. Now, this is, the old term would be a dual-edged sword. This is very powerful. So I can go in, I can try some optimization or make some big changes, and if I don't like it, I can just X out. But that also means that if you go in and make a bunch of changes, don't save it to the hard drive, and then X out, you're going to lose your work. So what I tend to do is I make some changes on things, and then I hit the green check mark. Sometimes I save it to the hard drive, and then I just open it back up, and I do some more changes. And I know it's a little bit of a nuisance to do that. It's different than other programs. And this is such an important topic that we have an entire video to show people how to do this and what there is about this check mark and X mark. The other thing that I will mention, if we go here to wavelengths, for example, and I'm going to change this now to 47, just some other, no, I'm not going to do 47. I'll do 500. So that's 500 nanometers, 0.5 micrometers. And now I hit green check mark, and then I hit the X because I called this from in the hierarchy underneath the surface data spreadsheet. If I go back to this wavelength, it's changed back because I X'd out of a higher level in the hierarchy spreadsheet. So be really careful when you're cascading your spreadsheets together, and just get used to doing a little bit of saving and using the green check mark and red X. When used correctly, it's used like an undo, and it's terrific, but it is a little different. So I spent a lot of time on that because over the years, sales and marketing has told me this is the number one thing that new users struggle with, is how to use that most effectively. All right, I think I've done an enormous amount. It's the second video in our OSLO beginner and overview videos. I'll show the website at some point. Command line, it can go up to 256 characters. I already showed if you click on it, left click on it, on this little arrow, you will actually show a list of commands that have been called. It's a history buffer. There's also ways to get to it. You can play around with these if you want, where you press F4, and that will actually pull them up. And you can do control page up and control page down to, to scroll up and down in there if you really want to. There is something funny within OSLO worth showing, another little quirk. So right here, if I go to this command and I do this, if I right click, I can cut or copy this or paste it. I'm not sure, Control X and Control C might actually work on it, but cutting and pasting right click only does work on that. But you can't use these buttons in here for it. So you're either doing it with a keystroke on certain things or right click. Now, if you want to edit a command, like let's say we ran one, and you want to actually edit it, so I want to run this again, and I want to change something here, I would need to click on this and then just change it. That's, I think, hopefully relatively straightforward. And when you make a change, if you want to run this again, you can actually use these buttons up here. Oh, one thing I forgot to mention on those is you can actually, the real fast way to do this is open the spreadsheet, then you do Shift Enter to accept, Shift Escape to close, or to cancel. So I find myself using Shift Enter and Shift Escape a lot more than actually clicking on the buttons. All right, hopefully everybody's still awake. The command line syntax, OSLO is built on something called AppMan, and AppMan is essentially its own programming language that's based on C. And the person who wrote it, Gordon Spencer, he actually made it unbelievably flexible. It's incredibly flexible. So the command structure can be a little bit flexible. So you can type them in almost like you're typing in a command in a very syntax picky language like C, but you can also put it in with spaces in. So there's multiple different ways to call this. This pen4 is just another command, but it shows that you can run multiple commands on the command line by separating them with a semicolon. So draw rays will just draw some rays in the drawing. Pen4 will change the pen first, and then this draw rays will do the same thing as what we have up top. Commands have short and long versions. DRR is an alias that's equivalent to draw rays. One of the most awesome things in OSLO is this question mark force prompt. If I type in something like draw rays with a question mark, it will then prompt me to enter other things in. I'll show that in a moment. The other thing we can do is enter information as a calculator, and I'm just going to show this because this is really actually we'll just do it in the exercises. I usually show it and then we do it in the exercises. I'll do it a little faster this time, but I do want to show the force prompt because the force prompt is fantastic. So let's say I want to calculate the idle aberrations, and I happen to know the command is SEI. But I can't remember if I want, and I type this in, I just do SEI. Now there is a way to get sidle aberrations down here, this SEI function, but notice that SEI function actually ran all of them. If I click here on this blue, it'll actually pull up the blue command, it'll actually pull up the command for that. So in addition to the yellow question marks, this is a way to find out things that have been run for text commands. Now we have this as well. Really useful. And I'll show a little bit in a later part of the class how to read all this, but you see here's the command name. But I don't really know what all these arguments are if I want to do, let's say I just want to print it from surface 3 to 5. So I do SEI, and I don't know them. I don't want to look the command up. I can do this force prompt where I do this question mark, and there are defaults that if you don't actually put arguments in, it will just go to the defaults that OSLO has defined. But if I want to do all of them, I just do all. If I want to do a certain number of surfaces, I do SRF. Now, the SEI command that I originally ran actually ran it as SEI surface 0, 0. Was that right? No, it ran just the image surface. Let's say I just want to do 3 to 5. I did SEI question mark, then it did SRF. Now I do the first surface in the range is 3, the second surface is 5. Now it says the wavelength, which I didn't even remember to ask for that. And there we go. Now it just ran it for 3 to 5. This another great thing about OSLO in addition to the spreadsheet buffer is the fact that you can infinitely customize the output because of your ability to call things, and with all of these arguments, it allows you to customize what users actually see or what you're actually printing out for something. So you can avoid walls of text with this if you really want to. But this example was really to show the force prompt. And you can use that with any command if you don't know what it is. So a trick that I commonly use is I'm too lazy to look it up. I type that in, and then here you notice it didn't actually save it in the echo that I have on. I remember I turned the echo on. It didn't save it that way. I come up here to the top. Look, it did save it in the history buffer. So this is the command we ran, SEI SRF 351. So I can cut this, paste it into something else, or just save it somewhere, or do whatever you want to do with it, or just run it again if you want, because I can run that command again. So what I sometimes do is run a command and then make a change, and then I just come up here and run the same command again without having to go into menus, without having to do anything fancy. The calculator mode, the only thing I'll say about that is right now, because we're going to do a little bit on it, is up here you can use this as a calculator. Be a little bit careful that you don't have a number selected in a spreadsheet, or you could actually change it. But I could do something like, what's 2 to the 9th power? 2 to the 9th power is 512. And it actually printed it out because, again, I have echo on. If I turn echo off, it'll stop doing that. So that's one example. Now, there are some funny ones. If I just typed in pi, all of a sudden it wants me to enter something. That's because PI is a paraxial solve command as well. So when you have that case, just put an operator of some sort in the front. So I do plus PI, and now it works. There's also a number of registers and names in here. So radius are all saved in RD. There's ones that are saved in things like thickness. So if I want to look at, let's say, like thickness 3, if I just do thickness 3 and I use the square brackets, if I'm looking at the array, that'll tell me what's in thickness 3, and so on. So there's a number of those, and there's actually also a number of global variables too. So that's what this A equals pi is I can actually type in A equals pi, and then I can then go, and this print just prints to the text window. I can print A now, and it'll print out pi there. Now that print doesn't actually put it into the spreadsheet buffer. There's another kind of print that does a print. So that's the next slide, is it just says what these global variables are. So scalars are essentially floating point types. I'm not sure how many bytes they are off the top of my head. We also have integer scalars. We have arguments 1, 2, 3, 4, 5, 6. You say, why in the world would you have A through H and O through Z and also have these arguments? The reason for that is these arguments were used back when we only had SCP and we didn't even have CCL in OSLO. There's actually also some arrays available and character arrays available in case you want to save a name like a path length or something and use it later. I've shown a lot of this already. Left click selects and right click pops up things. Double click so update graphics. You can grab to zoom graphics. There's other weird sort of little fun things you can do, some of which are actually really useful. Let me give you one good example of a shift click. So here I can click on this button. I can click and drag, but I can also click here, hold shift, and then click down lower and get this. And that's really useful if I have a long set of things where I may want to delete something out of it. Let me give you a really fast example of that. I'm just going to do some, oops. I'm going to generate an error function here. It doesn't really matter what it is at the moment. So just forget what I'm doing and just look at the, in terms of, I'll show all that later. Here I can come, select that row, and then select this, and I can do things like copy it, and I can also paste it into another file, and things like that. If I don't know that shift thing, this one was pretty easy because I didn't have to scroll down very far. But if you have to scroll down very far, or you need to go halfway through, it's really hard to click and drag to do that. It's real kind of pain in the neck. So I find that clicking and then holding down shift to select a subset, I find that to be much faster. And you can see here as I, well, there. Oh, look at that, it entered another one. As I do this and I go farther down, I can just keep selecting down that way, just as an example of it. So there are some things that you can do with shift click on things like the spreadsheet. Another thing you can do on spreadsheets is right click, and you can do things like in the surface data spreadsheet, you can insert things before or after. Another way to do that is you click on the row or get the row selected and you can insert before. So there's a number of things that you can do. So try the buttons out a little bit when you're first using it, and you'll see that there's actually quite a bit of flexibility in what buttons you're clicking. There's actually also ways to change and speed up the mouse wheel, but often people will control that with the interface versus in OSLO. There is one very, very key one that we have to show you. I showed you the clicking on a row here and then holding shift just because it's so useful to do that. But the one that you really have to know is, let's say I come here and I just want to copy. I can copy the entire window I can even copy just the page that's showing. But let's say I want to copy just some of the text. You have to come here, left click, hold down, select it, and then you right click, and that's how you can copy. And you cannot use Control C. The Control Copy doesn't work. You have to do it this way. Select, right click, copy selection. But because of the spreadsheet buffer, you can actually copy full precision, not just displayed precision. When you actually go to paste into other programs, make sure you know what we're using in here. Usually Calibri works to keep this formatting. I find if you paste into something like Word, often it puts it into Times New Roman, or I don't even know what Aptos does. I haven't tested that. But if you put it in and it puts it into something like Times New Roman, the formatting will get screwed up. So you can fix the formatting that came out of OSLO just by fixing the font. Yeah, that's not as great for reports and things if you're trying to show that, but usually people are doing graphics and reports and stuff. Sometimes what I also do is I just take a snippet using one of these screen grabs and just grab that part of it and just put it right in the document that way, unless it's going to change. But that's how you copy text. Taking a quick note, an idea of a video to do. Okay. A lot of ways to use the keyboard with the interface. Control and arrows helps you zoom graphics up and down. Shift arrows, you can do control page up and page down, which I'll just show. If I hold control and page up, page down, oops, got that selected. I hit F4. Now I believe I can go up and down with this with control, page up, page down. I don't know how many users use this. I know years back, an older user wanted to find out how to use OSLO without a mouse, and it is possible to do it with all this stuff. The only ones I tend to use are ones that make life easy and quick, like Control Escape to get out of the Surface Data editor when I don't want to save the changes. Do not save those changes. And then there's some other ones. Shift and Shift Tab, you can go between the different dialogues and spreadsheets. And you can also define some keystrokes as accelerators. So there's lots of things you can do. Okay, showing this off probably a little bit better. So again, we'll start with the demo triplet open. So I come here to the demo triplet. I'm going to right click this window and clear it. There's also other ways to do that. And I'm just going to put the picture of the lens up here. It says, open the surface data spreadsheet, change the radius of curvature to 1.5 times its current value. So here's the radius of curvature. I want to make it 1.5 times bigger. So what's nice about OSLO is all I have to do is times 1.05. And because this works like a calculator, now let's change it to 1.05 times bigger. It's 5. I'm sorry. I said 1.5. So I did it wrong. So I'm going to X out. Now I come in here, and now I come here and I can do times 1.5. And I can do that. So now this is changed to 1.5 times. Then it says reject the change, which I've already shown how to do since I didn't do it right. Undo all changes. Yes. All right. Now it says open the surface data spreadsheet, change the radius of curvature to 2% higher. I just did that. I'm going to actually change how I do this. So I'm going to come here. I'm going to right click down here in the text window. And this is where you can clear the text window. I just want it nice and clean. If you actually hit this lens button here, it will actually give you a prescription. So this has a spreadsheet cell. If I come here to this radius point, 21.25, The cell that I had down here that's A2 is that number from when I just dumped it into there. So I'm now going to take A2 and multiply that by 1.02. And when I do that, I actually got 1.02 times that value. So that's another thing that's nice to do. One of the ways I use this is I will actually dump data sometimes into this text editor, into the text window, and make some changes up here. And then I have an easy way to reverse any change that I did just by using the spreadsheet buffer. So that's in addition to the green check mark and red X. It says go to the help page for the Surface Data spreadsheet. To do that, just hit this question mark. Surface Data spreadsheet, help pops up. And now it says accept the change by closing the spreadsheet appropriately. So I go ahead and accept that. And then it says make a list of how you can use this accept and cancel feature to your advantages. So I don't save it, I'm going to actually go back to my hard drive saved version. So I did a file open and went back to that version. So how can we use the accept feature to our advantages? Well, you can X out to use it as an undo for multiple steps. You can use the X with some saves as well if you really want. You can put the data in the text window to help undo mistakes, which I mentioned that I do, especially with that Surface Data spreadsheet available. So if I enter a number in and I typed it in wrong, if I have that data down there, I don't have to X out. It's really useful when you do some things like optimize, where a bunch of numbers are being changed by OSLO. Didn't like it, you can just X out without having to open up some version of it that was on your spreadsheet, or sorry, on your hard drive. And there's a lot more things you can do with that. All right. Just file hierarchy. So OSLO puts things into a directory that has a public and a private. And I did not actually, give me just a moment here. I usually remember to open this, but for some reason I didn't. Okay. So here's the OSLO. It's got this bin, the bin, then there's a private and a public. So the private directory has very similar things as the public directory. For a few years, I go back using OSLO before Lambda Research owned it, and I knew Doug Sinclair and a bunch of the people that had worked on it. And for a few years, Lambda slipped a little bit and people were making changes in the public directory. Do not make changes in the public. If you want to make changes to something in the public directory, make a copy of it in the private directory and do it there. On things like CCL, if there's two things with the same name, the private directory will take precedence over the public directory. And that's very important. So that means you can customize. And the reason is if you make changes to the public directory, when we do an update, it may be or likely is to be overwritten by our changes. But the private directory is not overwritten when we do updates. So private files supersede public files. And one comment to make is when you do, if you make your own commands and things, you can't have things with multiple names for variables and functions. It will throw an error at you when you try to compile. Don't worry about that unless you actually do it. Most people, it's not a problem. We did have a user who wanted to do a lot of things within the private directory and had so many things going that we had to show him to essentially how to avoid that problem by not specifying, redeclaring functions over and over again in different files one time, and then that's it. The file system, again, public or read-only, for us only. We will make changes. When we make changes to the interface, I usually will write if there's enough changes, I'll usually write a user guide for the release for that as well. We have special file types. Actually, OSLO was the first of the design programs to use .len. Obviously, that's not the case now. So we actually also have this .osl. So if you have multiple design codes or multiple things using .len, you can try seeing if .osl will give you something unique. There's also .scp, .ccl, and there are databases, which we get into later, CDB files. We have this modified Windows dialog box I've mentioned where you can instantly go to the public and private. I didn't actually show it. I think I just mentioned it. But if we go to open something and I instantly want to go to the public directory, I can hit this button and it instantly goes to public and I can get into those lens files that are public. And one of the text editors, interestingly, also does that. Notepad++ will not do that. It's external, but this standard one will. If I go to open, it automatically can open to the private. You can actually also move it to the public directory. Why would you ever want to open a function within CCL, even if you don't do that stuff? Sometimes there's something you might want to look at within one of these public ones based on something you're doing, even if you aren't doing any programming yourself. Okay. Functional flow, again, OSLO is really built on CCL. It's really built on this thing called AppMan, which you can see right down here. I don't want to spend too much time on this, but basically everything flows through this main that is running through the executable that's running on C and AppMan, command line, CCP. Some of them users make a change or there's a command called and then OSLO runs and does something. Text windows, OSLO can put things to it or you can send something to OSLO from that text window. That's generally all that this is trying to show. Most of us now are not computer science people who do optics. There are some. So we don't want to spend too much time on those functional details. Documentation. So if you have a current support agreement, you can write us at support@lambdaresearch.com. Chances are I'll be the one answering you, although I'm not always the only one that answers the OSLO tickets. We have a lot of things on our website, which I'll get to in just a moment. Within OSLO, I've mentioned online, there's clicking on those yellow question marks. You can actually also hit F1. There's help buttons and different help command. Even if I just call up a generic command, I haven't done a lot here yet, but I call up this command, there's this help button that pulls you right to that page. Here under help, you can get right to it. And there's also F1, I believe, pulls up that main page. So here's the main page. Just note, these are hyperlinked externally, so they will go to an external site. And so we can click on these different ones to, and if we go to the download ones, for example, it will open up where it actually is on our site. But I just want to go through the website briefly here just to show you these things that I've been talking about. So here from our main Lambda research site, you go to support and OSLO, and you get this different set of things. We have some examples, knowledge base. We need to do some more updating on this. There's a number of different tips videos. And I don't like the Lambda bot, by the way. don't tell marketing. But go away. So here, if I'm going here and I click on different things, this will actually go to just a quick little video tip. We also have them posted on YouTube. So we have tips. Those are particularly useful. Some of the tutorials and examples they're a little bit older, but we also have some pretty extensive videos. Beginner and advanced. The beginner ones, I believe, right here. This is the check mark video that I was mentioning. So you thought it was tough to watch there. Apparently, I talked about it for 9.5 minutes when I recorded the video a few years ago. So there's a number of good ones in here. I always have a long list of videos. if there's one that you are just dying to see, you really want to see it, just send a note to the support and ask for that video, and I will see if I can get it enough of a priority. But we do like to know what our customers want. If you were to tell sales, it's likely to get to me too, or to get to us too. But it's okay to do it that way. We do like to be very responsive to those things. And there are a number. I have a big long list of ones I really do want to get to. Lots of things to do all the time. The other thing to show you on the web page here is if we go back. So I'm still in support right here on OSLO release. So here under OSLO release is where you have the current release. We limit how many past releases we give to customers, just as a matter of controlling how much we have to have available, and just good practice in general. One thing you can do, though, here at the bottom is the manuals. There's a couple other little things on here. So we do try to keep the website up to date as well. All right. So the main thing with the documentation is it's a combination of the in-program help. It's a combination of the program reference, which is kind of like the online one. Dave Jacobson says he tends to look in those printed manuals first. Actually, I have ones that are printed, but now we just have PDFs. You can look in the PDF. You can look in the OSLO online help. It's called online help, but it's really within the program. That's the one I tend to go to. And then we have one that's kind of independent, and it's one of the books. It's the optics reference. That's got a lot of background theory and information about how OSLO is running and how it ties into the physics. So there's your really low-level physics. We don't get down to the level of Born a Wolf, something like that. But we do tie together how OSLO relates to some of the theories that are in those types of references. We also have a user guide, which is great for new users, and it's got some pretty useful stuff in it. It's about 130, 140 pages. So I often will search any of these to find different things that I want. Okay, this one's a pretty quick one. We have our copy of OSLO open here. Oh, the manual's downloaded. I didn't actually open the manuals, but that's okay. I can get there really fast. Give me just a minute. Or can I? You know, I'm just going to do it from the website, I think, today. That makes some sense. Yeah, I'm just going to do it from the website because we have the current releases open. Okay. So what's the main difference between public and private? The answer is we change public, you can change private, and the public directory, if you make changes to it, they may be overwritten. If you want to get to a public lens file fast, where's a good place to look? Well, if you don't keep a link on your desktop, or you're not having that as your current directory, you don't have File Explorer open, or however you're doing it, a real fast way to do it is to just click here and hit public. So just open under the file, and then you can hit public. You get right there. If you want more instructions by videos, where do you get it? You get it from the web page. If you want extra practice, where can you find instruction and extra examples? Also the web page. I'll show more on the next slide. Where can you find out about a specific command or a command about printing refractive indices? So the ways to get to that, you could certainly look in the program reference. I tend to like looking here. You could even type in something like refractive index under search. And looking down a little bit, oh, I'm not even sure. If that's a good way to do that. Might not be the best way to actually get at that. One thing you could do is hit this, and in here you're going to have glass. So that'll take us to glass data and some refractive index information. in there, just as an example. I didn't show completely everything in the help. So this is compiled in HTML. So we actually have a contents here. So there's different sections depending on what you're looking for. So sometimes becoming familiar, like if, let's just say on the user interface, which is what we've been talking about, I want to know more about menus and toolbars. This may be a way to get started, or the command line with some extra information about how that runs, and so on. How can you find where something is in the interface? I didn't show this explicitly, but if you were really paying close attention, actually, let me do it this way. One thing you can do, of course, is just go through the interface. And let's say we want to know show surface data. So I click that there. I happen to know where it was there, but if I manage to find, the help page, you see it says view surface data, and there's a menu item here too. So if you know the name of a command, or it's shown up in the history buffer, or it's shown up down here, you can get to it that way. You can also look through contents or the index or search. So there's quite a few ways to find things. Occasionally, from time to time, it takes me a few minutes to find a little bit to find something, but usually it's pretty fast with all of those different ways to look stuff up. This one just says if you want to know the theory behind damp least squares or some optimization, where would you look? Well, that's the optics reference, most likely. Maybe the program reference for certain things. So this was just to be a quick reminder. Not really much of it. This is kind of the least exciting of the exercises we do. Let's see. Yep, website, user guide, and our videos are good. Optics reference. User guide actually has a lot of examples in it, so it is really good if you're just starting up. There are some also online and some other examples in the optics reference. Here I said in the program reference for looking up specific commands, but the in program may be easiest. Okay. All right, so moving on to preferences and operating conditions. I've given a little bit of a brief intro to them. So preferences apply to all files that are open. When we ship OSLO and it's installed, it's set with a certain set of choices for preferences. You saw what just happened to me. I opened something with a preference change that I didn't expect that I had changed, had to change it back for you. That was that spreadsheet curvature mode, but we don't ship it that way. Operating conditions are specific to each file as well. So preferences are for every file you open. They're global to any file any that you open within OSLO. Operating conditions are things that change depending on the different file that we have. And best to actually just look at what some of these are. So preferences determine program parameters. It turns out I've already been showing you one of these, but you just didn't necessarily know it. And that's this echo. That is a preference. So if I turn the echo preference on like that, then when I run a command, it will echo it here. If that is turned off, then it won't echo it. If I come here, there's other ways to actually open and close these. To set preferences, you can come here to, and by the way, I never do it this way. There's preference groups. You could do set preference, show preference. I just use STP, set preference. You can change them here with set preference, and there's even some that are in groups for different really common things like graphics. So if I go to graphics, for example, here's a little menu that allows me to change them through this interface versus changing them some other way. So one example, I said white background in graphics windows. I'm going to turn that off. Now all of a sudden, all my windows are a black background, dark background. Now, if I wanted to undo that, set preference. Oh, wow, look, okay, so this command ran that whole menu command, so it doesn't run like most of them do. That's interesting. So this is kind of gibberish to look at this way. So let's say I need to know this. I could go back into there, but let me show you another way to do it. If I just do this STP or I come here to the file, I could just run it under preferences and do set preference. But you know what else I could use? I could use our old friend, the forced prompt, STP question mark, and a menu comes down. Now I would have to actually know the name of this one, and here's where I embarrass myself because I can't remember it. Oh, here we go. Graphics white background on, and it changes it back. There's a similar set of commands and things to show preferences, SHP as well. The different values for preferences can be characters, they can be integers, they can be floating point, in other words, real, which is similar to floating point. It's specific to CCL. So it works great in OSLO. We also had them classified into different groups. Now, just like everything else, there's actually a place that we could go here. And actually take a look at preferences. So STP is the command to change preferences. You see this because I use the word preference. It keeps popping up. But here's a list of them on the preferences help page, which can be really good. Now, every time I look at this page, I see something that isn't incorrect, but it's not quite formatted exactly as I want. So I minimize how long I look at this, or I have to get into the HTML page and release a new version of it. But this is a great page. This is really, really good, really useful. And now is the time in the class. I apologize because I know it's not the most exciting, but we'll get to more interesting stuff very, very soon. Here's the help page that I mentioned. This shows you where you can actually get to it. Preferences under the setup. This is under the contents. So operating conditions can be somewhat found easily in the online help. It depends on which one it is. I say somewhat easily because some of them are easy to find and some aren't. So there's two that we've been sort of passively had working for us that I haven't shown yet. One is this general button here. This is the general operating conditions. This is where you can change things like the units. You can go focal or afocal. You can change this name to your own initials or your own name if you like, and then it'll change it to that. So now this says RNY here. I know it's a little bit small, so I can zoom in and show you it a little bit bigger. And a whole bunch of other little types of things as a little bit of a catch-all, but all pretty important things. And again, you can hit the question mark to see what those are. The other one that's pretty common is actually the lens drawing ones. And we've kind of been using it, not directly. If I go to the standard tools here, plan view, you see we trace these certain number of rays. It turns out this triplet is actually only tracing to 40% out in the pupil off axis. That's because the front and back lens here are cutting the light off. They're vignetting it. And OSLO's a little different than other design codes in the fact that when you vignette, you actually have to tell it to check a surface or it will just go ahead and ignore it. And I could do that if I wanted to here, just showing you that somewhere else in the class as well. So we're only showing part of the pupil there for the off axis, but the on axis is being drawn minimum and maximum. But we could draw, let's say 25 rays for the on axis. Now it didn't automatically update, but if I double click on the left, now I see I have these. So these control a whole bunch of the drawing. So I'll show a little bit more about that soon. This is where I think operating conditions are an excellent example of the forced prompt. UOC, update operating conditions, and question mark will pull up a list of all of them in the entire program. So we just looked at lens drawing, and there's also the general, which is the other one we looked at. Again, these spreadsheets are hierarchical because I called them from underneath the surface data. Yes, let's undo those changes. Okay, so general operating conditions. There's focal, afocal, I mentioned that, lens units. We'll skip the one I've made bold here just for the moment. You can pick where to put the reference sphere for some imaging types of analysis like wavefront. You can turn on or off aperture checking entirely. If you have it off, it will ignore anything where you're saying clip the light if this surface is too small for the light to get through. If you have it on, then when you specify a surface is checked, it will block the light. This ability to ignore the apertures in the lens in OSLO is part of why OSLO has actually been used to generate some unique configurations because of the freedom it gives a designer to do things you shouldn't do and then fix it later. And things you shouldn't do, I mean that as it's just a math problem sometimes when you're designing, and it doesn't matter if it's real until you finish. And if you can get something that's not quite real, like crossed over edges or having something not quite the right size, if you can re-optimize and fix it later, that's actually very useful in design to allow a design program to do things like that. So we have a few users that have taken very good advantage of that. Temperature and pressure, this is if you have a change in a stigmatic difference, and then if you are going to trace polarization on or off. Ray aiming is a deep topic. It's so deep that there's actually, let me show you, how deep is it? Yes, good question. I'm going to come back to our video page briefly and just show you how seriously we treat this subject. If you go to core use, I think it is, we go to core use, we have ray aiming 1, we have 7, 8, 9, all the way through 14 are all on ray aiming. And ray aiming in OSLO has, it just means how are we launching the rays into the system for that source. This isn't like Trace Pro where you define a source and fire rays into it. You define an object or object location, and then a stop is defined, and then ray aiming determines how accurately you're forcing the program to trace rays through the stop. Because you don't, sometimes you may want things to be faster, other times you want complete accuracy. Early in designs, it can be okay to have it being a little less accurate, and then as you go on, you make it more accurate. So there's a whole video set on this. There are, I will just show, actually in the program, it's good to show this. The default is to do the central reference ray. This is where you get the center of the rays in the bundles, all in the correct location of the stop. Paraxial, launching towards the entrance pupil is equivalent to just launching as if the entrance pupil has no aberration from that to the stop. If the system has the stop in the front, then it's the same. Then you don't really have to do ray aiming because you're aiming directly at the stop. But if you're aiming at systems where the stop is internal or behind the system, then in those cases, he's ray aiming. Central ray gets that central ray in the bundles to go through the correct location. That is where it crosses the axis, is where the stop is defined. Rim does a subset, top, bottom, left, right, and middle. Top, bottom, left, right, and middle. Wide angle traces to get them exactly where they should be going in the pupil. So this is equivalent to ray aiming in ZMAX. If you've used that, I have no idea what Code 5 does internally because they're closed architecture. And I'm not sure about some of the other programs. Everyone has to deal with this problem in an imaging design code because you have to trace a certain set of rays to do evaluation. So, and then there's extended aperture. There's another one, extended aperture is for things like if I have a very huge numerical aperture coming out of something in the front. So if wide angle mode works and you always and you don't care about the speed hit, that is the quote unquote accurate one. Central reference ray though can be used even if you have vignetting by setting something called vignetting factors. Okay, that's as much as I can say about it now. That's just where it's located. There's a whole bunch of other operating conditions that I showed some of, like designers putting the OPD in waves and other things. If you heard a noise, I just had two cats go after each other, but the door is closed, so I don't know if you could hear it. We have two cats that don't like each other, and they make sure we know they don't like each other sometimes. Okay, the drawing operating conditions. So in the drawing operating conditions, I've already shown you that controls the drawings. Rays drawn, you can control initial and final distances, 3D information, and so on. One thing that I want to tell you and point out here is when we define things like field points and pupil sizes, they are normalized coordinates. So 1.0 means 1.0 times however you've defined the field of view. So here we have defined our field angle as 20. So for an FBY of 1.0, that's 20. FPY of 0 is FBY of 0 is right on axis. So they are normalized coordinates that we use. There are some system notes here. They're good for documenting a lens file. Not sure what this one has in it. This one has a description of the Cook triplet. Its original design, this actually form of it was in Rudolph Kingslake's 1978 lens design fundamental book. The first form of this was designed in 1895 by Dennis Taylor. It still has some uses as a very low-cost objective. Don't know if it's quite as widely used now. So that's an example of those nice system notes. The system notes, they're a little quirky when you first use them because you type in the text and it pretty much just ends. So once you fill it in, it's not going to automatically scroll to the next one. And you can even see in here, this says configure as an abbreviation for configurations. That's because to type out all of configurations would have actually taken too many letters. So there's 5 lines that we show you. There are actually another 5. 6 is used by optimization. And if you want to use more, using 10 is fine. The problem is the easiest way to read this, of course, is to look. The easiest way to read these is to just look and click right here. If you don't do it that way, then you have to show that information. I didn't show a lot of the menus, but there's lens, evaluate, optimize, tolerance, source. And a lot of these things can be done by buttons and everything else. So a lot of these are things that put information into the text window on the system. We also have evaluate. Some are graphical, some are actually text. Optimize we'll get to a lot later. Tolerance we'll get to a little bit. That's where all the tolerancing works on. We can do some defining of sources. This is CCL stuff. Then there's windows and help. There's quite a bit in OSLO considering the menus don't look like there's as much as there really is, because a lot of them have a lot of pull down options as well. So here, as I was talking about surface notes, we go to surface data. And if I just do all data and I hit OK, the system notes do print out there. And you can see 10 is used here and it says Cook triplet. There are also surface notes that you can put in on something. I'm just going to type hello in here. And then if I hit Len again, see, notice there was nothing in here now. If I hit here under surface note, it says hello. Whereas up here, way back up here, it didn't have that. So there are system notes and then there are surface notes. There's a few other things that would be nice if OSLO would do, like changing the names from numbers, but it doesn't do that. So if I really need to do that, I'm keeping track of it, or I even write it on a little sticky note or something for what I'm doing on that. I mentioned surface notes already. All right, a few more exercises just to keep us awake and moving. So state the difference between operating conditions and preferences, and verifying the difference is optional. To verify the difference, you would basically, make a change to an operating condition, make a change to a preference, go to a different file, and you'll see, oh, the preference stays the same, even though I'm in a new file. It's that thing I changed it to, and the condition, operating condition I changed to, like let's say I changed the units to meters, and in the new file, and it was still on the default, it's millimeters. This is update graphics 1 for the normal plan view, plan graphics view, number 2. Change the drawing of the lens to 27 rays. So I don't think you can do it from here. Let me see. Right click. So UOC DRL or UOC question mark can get to it. But right here under lens is the lens drawing conditions. So here I can go to 27. So there I do 27. I hit OK. And now you can see the auto draw automatically change it. And when I double click and update this graphics window, that's what it has in it. I'm going to get rid of this down here. Okay. Update the number 1 graphics window for the 2. Oh yeah. So I double click. So this was 4 was to update that window. Now, right now, I'm not actually drawing the stop. I know from here, it's roughly somewhere here in the middle of this negative lens, or around that point, depending on the field point and how it's calculated. The actual location of the stop should stay the same, but the entrance and exit pupil would be different. But here the stop has to be in this location, so it is the same for all field points. And with the central reference ray on, you should be getting the correct location for each of those field points for the pupil, or for the stop, I should say. So this is telling us to draw the stop. Well, I didn't show how to do that, but it turns out it's not on by default, and it's because it's an operating condition. If you have certain operating conditions you like, you might want to make a template for a lens file that you use. Just make a lens file with the changes you like, or write a quick little set of command lines that you just run when you open a file and change stuff. So here I changed the stop to on. You see now it's drawing the stop here in the system. This isn't the best example for it because the stop is sort of internal to this lens while it's right on this back surface, so it looks a little bit funny. And it says, what's happening with the full field of rays? Well, they're getting vignetted. This front surface, and oh, one thing I didn't show on the auto draw is if you click on a surface, notice this went maybe a little hard to see, but notice 1 is now dotted. If I select 1 and 2, now both of those are dotted. 3 is now dotted. Anyway, so you can see which surface you're on by clicking here if you have the auto draw on. It's one way to tell a surface number fast. If you're not sure, you have some lens with a lot of different surfaces in it. So there's our draw. Let's see, what were they doing? So what's happening here is the full set of rays are being truncated by this first and last surface. And the first and last surface have these Ks on, which is telling us that they're checked, which means that it will block light at the specified aperture radius that we have. So it's actually truncating the light at those points. So it's truncating the light. It would actually truncate it here at the edge. Here we go, just 40% up and down, which is why it's not going all the way to the edge. All right. Change the design general conditions to your initials. I already showed that general, and you can change to your initials right there. Open the system notes. Here's the system notes, and if you want to change it, you can just click here and make changes to it as you'd like. Print out the system and surface notes. Well, I showed the surface notes you can do by doing the len, for example. And the system notes, I actually looked for it right before the class, and I usually just get it with the all data. But there's a command, actually, for this. So we'll go here to conditions, OPC. So to get the system notes, it's system notes here. So to do system notes, it's this SNO. I haven't shown how to understand these yet, but if you come here and we just do UOC SNO, oops. What is that? Oh, sorry. That's not the right way to do it. My apology. Oh, it's not GLC. Uh-oh. Here we go. I finally forgot a command for class. I was doing so well, too. OPC, not UOC. I was opening the notes, and they are an operating condition. So OPC, and if I do question mark, it'll allow me to do SNO. So OPC SNO is another way to do it. And I'm not sure if it's anywhere in the interface on that one. So this is just to show you a few of these options of how to do this stuff. Okay, finally out of the interface and into a little bit more optics. So the surface data spreadsheet is the main way we define systems. Works a lot like a normal spreadsheet, as I said. Few differences. We're going to talk a little bit. Here's the general interface. You can type in names. You can have multiple configurations. The EFL is calculated, so you can't change that. Wavelength, you could just type in a number, but it actually pulls down. Wavelength's a real funny one because this is the current wavelength, but it actually has a pull-down menu as well, and there's also a spreadsheet. So there's a number of different things with that. Some of these are just numbers that you enter as well. Here's if you want to change surface radius or thicknesses or aperture radius and so forth. These buttons up here, we've shown some of them. There's a general one. There's one to do setup. There's one to change a wavelength. I've shown that a lot. There's one to define different field points, which is used, can be used in evaluation and certainly is used in optimization most of the time. Variables tells you what you're going to vary, either as a compensator and tolerancing or have the optimizer change it. This draw on and off I've shown a bunch of times. There's a way to group elements or not. Things like catalog lenses, you can actually go in here and group things. This group button will just show things as groups or as individual surfaces, even if they are grouped. And then surface notes. The special surface data, which is this last button, and then the zoom data, really we're going to get into that a lot more in 102. So here under the surface data, you can see we have the surface, radius, thickness, aperture radius, glass, and special. Again, I apologize. I had the this specified as curvature with a preference to start the class. These conventions go back a long way in the optical design field. So the convention is these programs tend to work in local coordinate systems. And you can specify things if you choose to do that within OSLO and set it up appropriately to do things in global coordinates. But in local coordinates, the thickness applies to the previous, there's a surface, and then the thickness, the number associated with it, goes to the previous surface. So here for this little singlet, we have the object, which is surface 0, then thickness 0. Then we have surface 1 with radius 1. Then the thickness after that, the axial length, is thickness 1. And then there's surface 2, thickness 2. In this case, the image is surface 3. So OSLO, for optimization, OSLO, just so you know, does use curvature instead of radius. There's some intelligence behind that. It's annoys some people. If you do need to put in like a restriction on radius, just type in 1 over the radius and it'll take care of it for you. Image properties are calculated after the image thickness. This is another quirk. Not all design programs allow you to use the last thickness. OSLO does. So if I put a number in here, let's pop up I am so sick of this lens. Let's use this one. This is a laser doublet, which is great because it's got absolutely amazing performance. because it's narrow field, single color, designed to be perfect for that specific condition. Okay, so here we go. If I actually change this to 100 micrometers, do we think that's going to change anything? Well, I think it will. Let's go here to graphics window 4 to compare. So on my standard tools, and I hit this, and whoa, I've really crashed it out. 100 microns, pretty big difference. Through focus for this thing, when you shift 100 microns, you're really down into garbage land for the speed that this lens is running at, which it's running at f2. So it's, even though it's perfect, it is fast, relatively fast. So now we do 20 micrometers. I can do a quick comparison. There we go. So we've lost it. We've shifted out of the focus. Here's our through focus. This is at 25 cycles per millimeter, and it really degrades the performance. So the image properties are calculated after the image thickness. I love this. I think it's great because you can put solves and things on these last surfaces and then still change the curvature of the image surface or the thickness to refocus or defocus it. Okay, radius of curvature, a radius of 0 really means it's flat. This is why I actually kind of like curvature, because if I do minus 0.1 to 0.1 in curvature, it's pretty meaningful, but it's kind of hard to get things that are really flat with radius doing that. SCVM changed that preference. I had curvature or radius earlier. Okay, so we can actually just change numbers in here. You can put solves on. You can also do pickups, and you can make things a variable. So I'm going to show this for the curvatures, but recognize that for things like apertures, there's a few differences, and for thickness, there's a few differences. But generally, I'm only going to show this once. So this button here controls these different options. You can directly specify, which would help you, like if I put a solve on one of these. Actually, I'm just going to do it for thickness. If I put a solve on here, and that shifted it off of the focus that we had to the paraxial calculation for the focus. If I go back to direct specify, it doesn't go back to the number I had, but it does get rid of the fact I had a solve on there. So solves are for things, different things for thickness. There's a number of different solves for axial ray height, chief ray height, or even edge thickness. For radius of curvature, we can do a lot of different ones, including ray angles for the axial ray or the chief ray. Now, when we say axial ray, we mean the ray in the center of the field of view that's out at the edge of the stop. So it's the marginal ray, if you do a lot of geometrical optics. The chief ray means what I now have been forced to call the formal chief ray. That's the ray that's at the edge of the field of view that goes through the center of the stop. The correct term for that central ray in a bundle for off-axis is actually principal ray. However, when a lot of electronic sensors came to be, the sensor people started calling all of them chief ray, and so now everybody thinks the chief ray is for all field points. I gave up that fight years ago. So I call it formal chief ray for the edge of the field of view. But within OSLO, for this, chief ray means the edge of the field of view. So that is, here this is a boring lens because the chief ray, the field of view is so small, but I can set solves to that. You can also do pickups. So pickups are nice. Like let's say I wanted to make this surface here the negative of this surface. Now there is a convention that radii are positive if the center of the radius of curvature is to the right of the surface. If the center of the radius of curvature is to the left, it's negative. So this biconvex lens here, it's very slightly biconvex. This back one is not quite flat. It's got its radius of curvature to the left, so it's negative. So that's the convention for radius. For thickness, it's always positive unless you have reflections. And this was something that, again, early design codes made this choice, which was good for the programmers, not so great for the users. Odd number of reflections have negative thickness. You basically flip the thickness to a negative value to mean a positive value. And I'll show that when we show the Hubble Space Telescope a little bit later, very soon. So if I want this curvature to have a pickup and be the same value but the opposite sign, in this case, because the radius of curvature I want to be the left, I can do that, and I chose surface 1. I didn't do a multiplier or anything else fancy. And you can see now this 41.04 is, did I do that right? Well, anyway, it doesn't really matter. I've now got, I did a positive curvature pickup, which is fine. So I did a positive curvature pickup, which of course probably makes this total garbage. Let me do a negative curvature pickup like I meant to. I could have done a -1 multiplying factor there to do this, but I won't. There we go. This won't be quite as horrific, but it'll still be bad. So this now is the same curvature as the first surface, just with the opposite sign, and of course a lot smaller. Still bad, but not quite as bad. So that's a pickup. Really useful, tie different surfaces together, make lenses the same, have the same airspace in different places, have the same aperture radius on things, all kinds of stuff you can do, because now if I go in here and I change this to 40, this other one is now changed to -40 to match. Oops, that's not so good. Go back to 41. But if I go in here and I change this now to -39, for example, I've now done a direct spec and that pickup is gone. So pickups are really great, really useful for lots of things. So that's pickups. There are ways to do user-defined pickups too, which can be done with SCP. Variables. If I want to set something as a variable, I can either click here on this button, set it to a variable. If I click on this thing called special variable, that will do the same exact thing, but it will happen to open the variable spreadsheet editor. You can also go to this variable button and it opens the variable spreadsheet. So you can make lots of different things within OSLO variables. You can make variables for a current configuration. You can make it for all configurations if there are multiple configurations, like a zoom lens or even scanning things. Or you can actually also make it just for, so you can make different ones for different configurations. You can make it the same for all of them. If you don't have a system with multiple configurations, it doesn't matter. Variables, I've already talked about that. All those. Okay. Thickness. Couple little things. Infinity is 1 times 10 to the 20th, but recognize that any value over 1 times 10 to the 8 is considered, anything less than 1 times 10 to the 8 is considered finite within OSLO. And that's whether you're dealing in meters or millimeters. The gray button, we have direct spec, solves, pickups, and variables, very much like curvature. Now, the thickness of the image surface, I've already mentioned that you can actually change that and change where things are being evaluated. It actually matters. However, in afocal, it does not matter. When you have an afocal system, it's collimated in the back. So changing that distance doesn't do anything. There's also a gray button displays in thickness, all of these other sorts of options, but there are some special ones on the last surface where you can do things like click here and I can autofocus. That just does a real quick calculation of autofocusing. So right now I've screwed this image up. Because this system is so good, I'm going to use wavefront. It's only a single wavelength, but I'm going to go ahead and it's actually a very small field of view. So if I do on-axis monochromatic, you can see here that calculation got us a little bit closer, but I've screwed up these numbers so much it's actually not well optimized anymore. But we do get closer with that focus, but this system is now a mess. It's so fast that when I make those changes, we've just cranked in so much spherical aberration. Whoops. Somewhere I managed to save those results I didn't like. So I come into here and let's just say I changed this number to 32.2. And now we just go, let's see if we can autofocus that back out. Oh, wrong graphic. So we're pretty defocused here. So let's try to see if we can just refocus it out. This, like I said, is not necessarily the calculation that you would always want to be using, but look at that. So 32.2, it defocused at 0.197167, almost as good as it was before. If I undo that, it was 32.2. You saw it was 32.398. So there's a few extra things with that image surface that's nice. Glasses have a number of different things you can do that are a little bit different. There are some ways to do pickups and other stuff, but let me go to the program to show this. So here, reflect allows you to do mirrors. Reflect hatch just draws it as a mirror with a hatch. I'm actually going to go to the Hubble real fast. So here's the Hubble. It's a hatched surface there. So you can see it says reflect hatch. You can also go when you pull this down, you can do pickups. So you can have surfaces. You can see this LASF35 is a pickup. So if I change this glass on the first lens, it's going to change it to the same one on the second. Catalogs just changes to catalogs. Now, when catalogs become obsolete, we put them into these obsolete. So you'll see that. So that's when they're no longer manufactured. There's some miscellaneous that have a bunch of different ones in it, like germanium, some of the IR stuff. I think maybe some plastics are in here too. Yeah, polycarbonate, and so on. So this is where we get this. This isn't the only place to do glass stuff. We actually also have glass databases, but this is where you do the entry. If you know the name, you can just type it in. If you don't, you may need to find it. Model glass is where you specify just an index and an Abbe number. And when you do those, when you set it up that way, you can do optimization and things with it. Direct just allows you to specify an index for all the wavelengths you've defined. And then this is also where we do internal transmittance and birefringence. Fixing a glass, by the way, when you actually go to fix right here, if I go to a model, so I just make this a model really fast. Now, if I go and I can fix it, it can fix it to a catalog. You can have your own private catalog that you fix things to, and that will actually fix it to the nearest real glass. I often just do it manually still because I like to look at all the properties within it. Okay, we have the next set of exercises. So with auto draw on open, when you open the lens, this is when we open the demo triplet. So here I'm gonna get out of that, go to our demo triplet. And actually, I must have changed it somewhere in here, but actually the auto draw should be on normally. Always a risk in this class that I made some change. All right. And it says toggle the auto draw on and off. Pretty straightforward. Update the graphics window to draw the lens. Okay. Here it's already drawing it. If I come here to plan, I will draw the lens. Change the sign of one radius of curvature and note the change in auto draw only. The only reason to do this is just to show you that the radius changes. So let's do minus 21. Oh, actually, one thing I can do is just multiply it by -1. So that'll change it. Keep it the same. Notice the auto draw changed. The other window didn't change. You can do the same thing by changing a glass. So instead of SK16, just taking a quick look, I did RIN. I did this command just to look at the glasses. SK16162. I can't remember one right off the top of my head. We'll just go with SF2 is a lot higher index, but I'll do it anyway. So now I changed that, and it actually changed things further. You really couldn't. I guess I would have had to have done that. Let's do it this way. Let's really go for it and do SF57. So keep an eye here on this, on these two windows. Like we believe, you just do it. Ooh, that's G57. So when we do that, this one changed, this one at the top didn't. All right, fine, goody. Print the lens data in the text window. I'm going to right click here and clear the window and spreadsheet buffer. TWR is the command that does that. I can't remember. You might be able to clear it here too. Yeah, reset might actually be the thing to do that. You can actually put titles on things and all kinds of fun stuff up there too if you really want. So now it says to print the lens data. So len was one way to do it. Another command for it was RTG, does some of them. Radius thickness glass, I think is what that stands for. Lens data, and then it says put an axial ray solved to equal 0 on the thickness after the last lens. Okay. So this solve here, we want to do an axial ray height to make it 0. You can see we've shifted away. So now we've shifted away. That would change the performance normally. It now says change the thickness of the last lens to 10% higher. And I'm mainly doing this just to show you how easy it is to do some of this stuff. Times 1.1, so that would be 10% higher. There we go. And the solve quantity disappeared as I expected it to. We could try to autofocus this. In this case, because it's not a great lens in terms of performance, we are just going to go ahead and try spot size. You can see, if you know how to read these ray intercept curves, a slope on all of them like this means we're just heavily defocused. So here we go to autofocus, spot size, field average, polychromatic, I think is what I say. Yep. So we do that, and you see it's just a humongous amount for the changes I've made. 4.4. And it's very, very far. Now, I don't know if I did this in the right order. If I go here to axial ray height, go back to that, and then I come here to, oh, I think I did something wrong. Let me see what I did. Huh, that's interesting. Oh, I know what it told me to do. I didn't do this right. It told me to make this 10% higher, so that would be 2.2. That's what it told me. I'm sorry about that. I didn't follow my own instructions. So there we go. Now we do this refocus. And we do field average, polychromatic, spot size. And you can see it wants to shift 100 microns. That's a lot better. So it brings it back in a little bit closer to where it was, maybe not exact from what it was initially. This just has, as a reminder, if we open this Hubble example, I haven't shown where the Hubble actually is, but a lot of these are in public, and then the different demo. I think this one, is this EDU? Yeah, it's in the EDU folder. So here's the Hubble, and it just says, why is this surface negative? Well, after we hit this, you have to do negative if you're going back to the left. Then when we hit this secondary mirror, it's going back to the right, and the thickness changes back to positive. So here's the exercises with the surface data and surface data spreadsheet. So we're a little bit behind, not too far, about 10 10 slides or so. I don't want to go over very much because it's different time for different people. The next time we'll just basically go through the setup, which is another button. We'll do a little bit more on wavelengths, and apertures need to be talked about separately from the other columns in the spreadsheet editor. So here's our spreadsheet editor. We need to talk about the apertures separately, simply because there's some different things that you can do and specialty kinds of things that you can do with them. So a little bit on special apertures, just a little bit on coordinates, talking about solves again. So it's not too much time, but I don't like to go over. When we go into tomorrow's class, so it's going to be a lot more interesting tomorrow. The first day is always sort of the toughest one to get through. It's a lot of interface stuff. It's a lot of, and if you haven't used this code, I know it's a lot of really new stuff if you haven't done a lot of optics. So the notes are made to where you can go back and look at them and practice more. So this should be a piece of your learning. What we'll do next time then is we'll do variables and optimization, and we'll do evaluating performance, and we'll just give an idea of the evaluation of performance. So today was about the interface, a little bit how to set things up, then to do basic design stuff with variables and optimization. A lot of that's tomorrow, and then a little bit on evaluation. So I'll hang around a few extra minutes if there are any questions, but we'll start up same time tomorrow that we started today.
Okay, maybe can I just ask a question, sir?
Absolutely.
Okay, for me, I need 2 points. I don't know if we are speaking about that tomorrow, but first, I'm not clear about what are the interpretation of the different graphics when I'm focusing or not. So I need some explanation about the interpretation of the graphics. We have several graphics, and I'm not clear about the specification. Yes, all this one. So if we can take a moment to explain the interpretation of the different kind of graphics.
I'll talk about it a little bit, but let me just show you just these basic ones. So these are called, I'm not going to do it with the Hubble. I'm going to do it with the, laser doublet. So what this graphic is, this shows you where, this one's a little bit difficult. These are called ray intercept curves or transverse ray aberrations. They are things that a lot of people don't, like program management tends to not use them. The designer does though, because you can really tell what's wrong with a lens with them if you learn how to read them. And essentially they're different shapes depending on the kind of aberration that you have. And I don't have a slide that really shows that. It's a little bit of it's in the optics reference. But essentially what this is if I trace a ray, this is plotting where it is in the bundle, in the pupil, relative to where it goes on the image surface. The triplet's not a great thing to do this with. So this is going to focus down.
I don't need the answer now because I saw some people are leaving. But
I can do it quicker. That one's the hard one. This just shows how the fields curve. This shows how spherical aberration changes. If there's changes in focus for color, that's what this one shows. This is distortion. So these are all different plots that you use as analysis. The other common one I showed, spot diagrams are easy, or these are wavefronts. So these show how close we are to wavefront. Spot diagrams are easy though. It's basically fire a bunch of rays through, and where do they go in the image plane? And we just plot them as like little arrows, kind of like we're shooting little arrows and where they go.
Wait a second. In fact, I play with OSLO. I made several design.
Yeah.
But no, I know these graphics, but I don't know how to interpret it very clearly. So my question is, in OSLO 101 or 102, we will see in detail how to interpret this kind of results.
A little bit. That's hard to do because in this sort of a class. Okay. We have talked about having an optics class where we go through that. I think we do need one because otherwise you've got to pick up a lens design book or read read the optics reference is one good place. And if you have a decent physics background or EE or systems engineering, a lot of different backgrounds, you'll be able to read it and you'll understand what it's doing. It's just a combination. Some show rays, some show what happens at the image plane, some shows what's happening. Wavefront would be a perfect sphere if it was going to be a perfect image. And you compare to that perfect sphere. A lot of space instruments do that. This one's called MTF. A little bit harder to understand. It's if you have a picket fence, how well are those frequencies reproduced? This is basically the transfer function for the system. So if you haven't done a lot of that, it's part of the exercise to get used to it. The fields that have the most trouble, if you've done material science, you maybe haven't done as much of that. And then mechanical engineering is very different than that. It's generally not this. It's more like electrical engineering than mechanical. So I don't really say a lot of what they are, but I'll show you later in the notes. We do go through getting there. We do go through a number of different analysis, and near the end, I at least mention what these different ones are called.
Okay, fine. And just to finish, I'm sorry, but
you're good.
I also want to modelize a beam splitter, and I never find how to do it. Is it something we are to explore or answer or something like that in the 2 course?
What kind of beam splitter?
I use a cube.
A cube?
Yeah. I can modelize one pass, but I don't know how to modelize the second one. So
a double pass.
Yes, I have. In a beam splitter, you have 2 pass.
Right.
And I'm looking to modelize the 2 pass, and I don't know how to do that. I don't know if this is also in the program of 101 or 102.
The reason why I pause is because you can setting up the geometry and tracing the light through can be done. Usually you would do one arm or the other with 2 different configurations. So you'd have the one that passes through, then the one that reflects. if you have that kind of a beam splitter. But things like coherence, you can do a little bit of partial coherence and stuff like that. So it depends on what you want to do. So setting the geometry up, we don't quite show you that. But I will see if I can find an example or remember where there's an example just of a cube beam splitter.
Fine. Very good. Thank you.
Because that requires, I mean, you're right. That is, so if you've used programs like Trace Pro, you just put the geometry in, you throw a source in, and it just does it. In OSLO, you have to work a little bit more to get that kind of a case.
Okay, fine. Thank you. See you tomorrow.
Yep. Is there anybody else with any questions? I still think we have some people here. No, but I think we're probably pretty good. I haven't seen any other questions. So great. Okay. I could say yes. And actually, are you in Europe?
Yes, I'm in Switzerland.
Okay, yeah. I knew we had one in Europe, so I apologize about the time. The November class will be at a much better time.
No, that's not a problem. In fact, morning is easier because I follow my day today. No, so it's 5:00 now, so I start my day. That's correct.
Wow. Okay.
No problem.
Okay, fantastic. Okay, great. Thank you so much. All right, everyone, I'm going to end the session.
All right.
Thank you.
So, take care. Have a good day.